Assalamu alaikum dear students, Zahir here and welcome back to your favorite channel Dr. Zahir Math. Because we used to say right, east or west, Dr. Zahir Math YouTube channel is the best. Last semester we completed MA301 differential equation with lot of struggles, right? There was no time and I was preparing for 4 courses, right? Yes, and now we are starting your next engineering math course, which is numerical methods for engineers, right? This course is especially important for mechanical, electrical and chemical engineering students. And trust me, you will use these methods in your real world engineering problems, right? So before starting this series or videos, let me tell you, where are you going to use this numerical methods in your major, right? So let's start with mechanical engineering first. So you will use this numerical method course in the first one, finite element analysis. It will help structural design by checking how strong and stable mechanical parts are under different forces. So in this place, you will use numerical methods course. The next very important one is computational fluid dynamics. Here, they uses fluid simulation to study and improve how liquids or gases move in systems like pipes or engines. The next is vibrational analysis. Keeps machinery stable by finding and fixing shakes that could break or slow down machines. Let's go with chemical engineering. So chemical engineering, the first thing is process simulation. It improves the reactor optimization by testing chemical processes to make them faster and safer, right? The next one is heat and mass transfer, right? Heat and mass transfer analysis looks at how heat and materials move to build better systems, like you can say heat exchangers, okay, right? Next is chemical kinetics modeling. It checks reaction speeds to make chemical processes in reactors works better. But electrical engineering, again I'm telling, most of the people electrical engineering, mechanical engineering, they will use in many places, right? The first thing, very interesting one, power system analysis for load flow. It checks how electricity moves in networks, right, to keep your power steady and reliable. Next, the very important course, which is a nice course, which is control systems. It designs for automation, creates systems to control machines automatically with accuracy. That's very, very important, this place. It means it's give you clear picture, clear decimal value it will give, right? The next thing is very important, circuit simulation. A lot of research are going on in this field. Okay, most of the people are using numerical methods for their research work. So this circuit simulation for transient analysis predicts how electrical circuits behave during quick changes or problems. Okay, right. So these are the few applications you can say where you're going to use numerical methods in your field of engineering. Of course, I know you don't like it, but still I need to tell some of the important applications, right? So in this MA301 course, before you start module 1, if you see the course description, they have given some topics as an introductory material. It means before you start to study this numerical methods course, you want to know some basic ideas. Okay. So what are the basic ideas you need to remember? The first one you're going to study, this is the first lecture, okay? So in this first lecture, you're going to see the first one is absolute error. Let me write it. What are the things you're going to study in this introduction? And it is not in your CLO, keep in your mind. It is just an introductory material. So the first one you're going to study is absolute error. Okay, error means what? Actually, in general, we say it's a mistake. But error means what we are going to say, the small minor changes in your decimal values, we call it as error. Okay, and, sorry. And the number 2, we are going to see as relative error. Absolute error, relative error. And the third idea which you are going to study is rounding and shopping. Rounding error and shopping error. You can say like that. So let me write rounding and shopping. Next, number 4 is computer errors. Number 4 is what? Computer errors, where it will happen in representing some numbers. Because computers cannot handle big numbers, cannot handle very small numbers also. The next, some approximations you are going to study using one series called Taylor series. Of course, you studied in some courses Taylor series. So these are the 5 chapters we are going to see in this video with the small examples. Okay, right. So let's go to the first one, which is absolute error. What do you mean by absolute error? Absolute error means it's the difference between the true value and the approximate value. What do you mean by true value? So true value in the sense, for example, suppose, let me say example, your mom is asking you to buy some tomatoes from the market. Okay, you go to the market, right? So you're buying 1 kilo of tomatoes. When you come back and you just weigh this tomato in your weighing machine at home, maybe it will give you, for example, 980 grams. Some 20 grams will be less, right? So that 1000 grams, that is 1 kilo, which you are buying from the market, it's a true value. And the approximate value is 980 grams. So that is called approximate value. Okay. So the error is true value minus approximate value. So the formula for the absolute error is absolute. The word itself coming absolute. Okay. So absolute error is equal to absolute value, true value minus approximate value. Okay. I call the true value as what? Which is P, right? And the approximate value, I call it as what? P star. So absolute value P minus P star is the formula. So just remember the formula. Let me give you one example. True value is 3.1416. Approximate value is 3.14. What is absolute error? Let me call it as P and I'll call it as P star. What is the formula? Absolute value P minus P star. Teacher, can I do P star minus P? Yes, it is absolute value. Okay. So 3.146 minus 3.14. Let me take the calculator. Okay. So which is equal to, right, 0.0016. So this is going to become your answer, right? So this is the way to calculate absolute error. It's so simple, right? Let's go to the next definition, relative error. So what do you mean by relative error? So the relative error is always going to be positive. Absolute error also going to be positive. Why? Because there is an absolute value. Okay. What do you mean by relative error? The definition says that relative error gives the size of the error in comparison to the true value. What is this, teacher? Don't worry, you just study the rule. What is the rule? The rule is absolute value, true value minus approximate value divided by true value. Okay, what is that? True value, right, minus approximate value, okay, divided by true value. Everything is under absolute value. Keep in your mind. So what is your true value? We call it as P. What is your approximate value? We call it as P star. What is your true value? Absolute value P. This is the formula to calculate the formula relative error. Clear, everybody? Relative error, right? Let me take some examples. Okay. So for example, if I calculate the same for the above question. Okay. So let me take the above examples. True value is equal to, so true value, which is P, is equal to, I'll take it as 3.1416 and P star, I'll take it as 3.14. So what will be your relative error? Okay. So the relative error is equal to, how we calculate the relative error? So the same thing, which is P minus P star absolute value divided by absolute value of P. So which is absolute value. Just now we calculated this value. Let me take it or do it again. Okay, I'll do it again, no problem. So 3.1416 minus 3.14 divided by absolute value of 3.1416. So let me put all these things in the calculator. So which is equal to 0.000509. So this is the relative error. Usually relative error, they give it in percentage. This is the usual practice. Teacher, why we should write? It's a such kind of practice. Okay. So always you try to write relative error in percentage. So percentage is small. You have to multiply by what? 100. Okay, right. So 0.000509 multiplied by 100. You can put in the calculator, no problem. So 0. I'm moving 2 decimals. So 0509. I think 1, 2, right. 0.0509 percentage. So usually relative error, try to give it in percentage. Can I give it like this, teacher? Yes, but somewhat it's not correct. Always they talk about relative error in percentage. So please try to give percentage. Let me do few more examples so you will get an idea of absolute error and relative error. Try to measure the length of the pen. Suppose you have a pen, right? The actual length of the pen is equal to 10 centimeter. But your ruler, you're measuring with the ruler. And your ruler gives what? 9.8 centimeter. I'm talking about pen. Keep in your mind. So the pen length is what? 10 centimeter. And the ruler says 9.8 centimeter. So what is the question? Calculate the absolute error and the relative error. So what is the formula for absolute error? Absolute error is equal to what? Absolute value P minus P star, which is equal to how much? Which is 10 centimeter minus 9 centimeter, which is equal to 0.2. So what is your relative error? The same formula, okay, which is absolute value P minus P star divided by absolute value of P, which is 0.2 divided by 9.8. I told you, give the answer in terms of what? Percentage. So if you multiply by this into 100, let me do it in the calculator, which is 0.2 divided by 9.8 and then multiply by 100 gives 2.04, something like that. So which is 0.2. Okay, sorry, I made a mistake, which is P, right? P is equal to how much? It is 10, which is not 9.8. So let me write this one. Fraction mode 0.2 divided by 10, which is equal to this one, multiply by 100, which gives exactly 2 percentage. So see, you can guess from here itself, see 0.2. So there is a small difference is what? 2 percentage difference. That's called relative error. That's clear. Let me do one more example, right? Same, which is an apple. Weight of an apple is 200 grams. Okay, right. Weight of an apple is what? 200 grams. So P is equal to 200. But when you are weighing with the machines, it gives what? 195 grams. Calculate the absolute error and relative error. So absolute error is equal to P minus P star absolute value, which is going to become 5, right? So I'm not going to write because 195. So relative error, the formula is what? Formula only you have to remember. P minus P star divided by absolute value of P. So which is 5 divided by 200. And I told you just multiply by 100. This is a usual practice. You are getting 2.5 percentage. Small number. So I'm just dividing in my mind. So I'm getting 2.5 percentage. Okay, right. So let's go to the next one. Next is called rounding error. You can say rounding error or you can say rounding. Okay, sorry, error is ERROR. Rounding error. What is rounding? We always used to say, most of the times we followed this practice. Rounding is reducing the number of significant digits in a number. Significant digits means it's a decimal values. Significant digits means what? Decimal values. For example, 3.6789. Okay, take this one. 3.6789. If you are rounding to 3 decimal places, whenever you are rounding to 3 decimal places, you have to see the 4th place. Keep in your mind, 4th place. If you are seeing 3 decimal places, you are going to rounding. It means see the 4th place. So what is going to be happen? 3.6789. You are going to round off to 3 decimals. So it will be 3.67 what? 9. So this is called rounding. It's very, very easy, right? So why we are doing this kind of things and all? Because computers can't solve all decimal digits. They stop at a few numbers. So we use this rounding, chopping to cut off extra digits. Computer in the sense, calculator also included. Okay, right. Keep in your mind. So let's go to the next one, chopping. Chopping means cutting off the digits after a certain number of decimal places without rounding. What is that? Suppose there is a number 3.6789. What is the question? Chopping to 3 decimal places. Chopping to 3 decimal places means you cut it in the third one. So which is 3.678. This is called chopping. Chopping means you no need to see the fourth one. No need to make it, if it is 5 and more than 5, no need to make it the number. But here, if the fourth number is more than 5, and then you have to change. More than or equal to, you can say like that, 5 and above. Then you have to change this number. But in chopping, no need to do that. Just if they say chop it 3 decimal, chop it 3 decimal. Suppose they ask it, chop it at 1 decimal. They say like this, chop it at 1 decimal. What's your answer? It's 3.6. Suppose they say here, round off 1 decimal. They say like this. What is answer? 3.7. Why? Because there is a 7. You're going to increase 1 here. So it's going to become 3.7. Okay, right. So let me give you one more example. There is no place. Let me give you one more example. Suppose I give you 3.1415. Okay. Let me say rounding to 2 digits. Let us say rounding to how many digits? 2 digits. Come on, rounding to 2 digits. See the third one. Is it more than or equal to 5? No. So rounding to 2 digits is 3.14. Right? Suppose I say rounding to 3 digits. Suppose I say rounding to 3 digits. So see the fourth one, it's 5. So what you need to do, you need to add 1. So which is 3.142. Okay. This is called what? Rounding. Suppose I say chopping. Chopping 2 decimals give you what? 3.14. Chopping 3 decimal, 3.141. So you understood what is rounding, what is chopping? It's very easy. It's a baby class. Okay. Right. The next one we are going to talk about is computer errors in representing numbers. Computers are not like human beings, like humans, like man, like women, whatever it is. Computers are not like human beings, right? They store in binaries. What do you mean by store in binaries? That means the computer takes a number, zeros and ones, and use fixed digits. It always use zeros and 1, not more than 1. You will give numbers, but inside, behind the PCs, it will take it as a number zeros and 1. So they can't store very big number or very small numbers correctly. So this leads to what? Errors, especially with very large numbers, very small numbers, or you can say decimal numbers, right? So think of a computer like a notebook with a limited space. So it can't write down all the digits of the number. For example, you take 1 by 3. Just now I gave an example, 1 by 3. So what is 1 by 3? 1 by 3 you just put in the calculator for 9 decimals. 1 divided by 3 you put it for 9 decimals. It gives 0.33333333. Still it continues. But the calculator gives only what? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So only it's giving 9 digits. What happened to the remaining digits? Again it continuing, right? 0.33333333. It continues because the calculator can store only 10 digits. It is giving, and 9 decimal digits only calculator can store. So that is why you can represent this number. So for example, suppose the computer or the calculator store it like this, 0.3333. Then what happens? There is a error, right? So that's what I explained. The error is equal to the computer stores, right? And what you are taking, for example, this is 0.3333. This is the original value, true value, right? And this is the approximate value, okay? Right. So the final answer is going to become what? This one. So it means, what is the final conclusion? The final conclusion is 1 by 3 is not stored exactly in the computer or calculator. So what is the meaning of that? There is a very small error, but it shows how even tiny differences in representation can affect results in large calculations. But okay. Now with this, another new definitions are coming. This type of problem. What type of problem? Original value is 0.33333333. It keeps going infinite. But the calculator stores how many values? Only 9 values. Infinite values, 9 values. Because of that, some errors are going to happen. The first one which you already studied is rounding error, right? We are rounding 0.333 like this. So this is called rounding error. The next one you are going to study is truncation error. The next one you are going to call it what? Truncation error. Truncation error caused by cutting off without rounding. You can say like that. Without rounding. It means what? Chopping. Right. The next is overflow and underflow. So there are three types of errors when you give the data inside your computer or in the calculator. What type of errors are there? Rounding error, truncation error, overflow and underflow. What is rounding error? We already studied rounding error, right? So no need of this one. So for example, you see here, pi, if you put in the calculator, you will get this one, 3.14159.265. Suppose you take it as 3.14, you round it to 2 decimals. But still it is going on, but the calculator gives what? Only up to this. So I calculated the error which is called as this one. Next we go for truncation error. Just now I said truncation error is nothing but what? Chopping error. So for example 5.6789. So if you want 2 decimals, you are cutting it as 5.67. So this is called what? Chopping, right? So what will be the error? This minus this. So you are going to get this error. So this is called truncation error. The next one is overflow. Overflow. The word itself giving overflow. So it means what? More. Error when a number is too large for the computer to store. Underflow. What do you mean by that? It is too small. Closer to 0 than the computer can handle. For example, you take this one in the calculator. E to the power of 1000. Value is what? The calculator will give you either error. But if you do it in the computer using MATLAB or something like that, it gives infinity. But still, there are some values are there. But the computer cannot able to give that value. That is why it is giving what? Infinity. Understand? Right. For example, let's give another one. You just divide in the calculator. 1 divided by 10 to the power of 400. If you do it in the calculator, 1 divided by 10 to the power of 400, the calculator gives math error. But at the same time, you do like this. 1 multiplied by 10 to the power of minus 400, it will give you some 0.000. Error means what? It cannot give you the answer. But when you reduce the numbers, you see, when you reduce, it gives some value 0.000. So this one only we call it as, and the number is too small, the error also too small. So that's called as underflow error. Okay. Now I made it as a small table. Rounding error, I gave an example. And truncation error, I gave an example. Overflow, I gave an example. Underflow, I gave an example. Okay, right. So this makes you to clear what is rounding error, what is chopping error, what is relative error, what is absolute error, what is computer error. Clear everybody? Right. So next we are going for Taylor series. So what is this Taylor series? Taylor series, right? It's like a series. Series means what? Summation, right? 1 plus 2 plus 3 plus like that. So what is this Taylor series? It is a way to approximate any function using powers of x. Just like we use the ruler to measure straight lines, right? How we measure the straight line? We use the ruler, right? The same thing. This Taylor series is the only way, easiest way to approximate any function, okay? Any function using powers of x. Using what? Powers of x. Right. Okay. Now, usually where we use this Taylor series, usually in calculus 3, we didn't study, but before your calculus 3, it was there. But might be you are studying calculus 2 somewhat, some portions. So where we use this Taylor series to estimate curved functions. What do you mean by curve? Always curve means you don't get idea. It's a different type of curves. So in general, I used to call complicated functions. I don't say curved functions. I say complicated functions. So let's start with the formula. Okay. So formula for Taylor series. There is a formula is there. What is that? F of x equals f of a plus f dash of a x minus a plus f double dash of a divided by factorial 2 x minus a the whole square plus f triple dash of a divided by factorial 3 So usually we write factorial 3 like this, but you write like this. Factorial 3, x minus a the whole cube, and so on. This is the formula to find what? Taylor's series. Why, teacher, you are writing this formula? What is the connection between the approximation? What is the connection between error in this? Wait and see. Right. So let me take for example, I take a is equal to 0. The neighborhood point I am taking as 0. So what happened to your formula? F of x equals f of 0 plus f dash of 0, x minus 0, right? Yes or no? Right. And then plus f double dash of 0, x square plus so on, right? So in simple, I want to write it as f of 0 plus x times f dash of 0 plus x square times f double dash of 0 and so on, right? Yes, and so on. Okay. Now this is the formula in the neighborhood of the point a equals what? 0. Then what is this formula? This is the general formula for any point. So this is the Taylor series formula at a equal to 0. How we are going to show this, teacher? Very simple example I am going to take it, which is f of x equals e power x. Right. What are the things we need? We need f dash, we need f double dash, right? And also we can take f triple dash also, no problem. So let me take f dash of x e power x. Let me take f double dash of x e power x, you know very well. Let me take f triple dash of x e power x. Let me start putting zeros. F dash of 0, 0 e power 0. So which is e power 0 is equal to what? 1. F double dash of 0, 1. F triple dash of 0, 1. F fourth derivative of 0, whatever it is, it's keep going. Everything will be 0. So let me write f of 0 is also 1. Okay, because second one is here and the third one is here. F double dash and f triple dash is here. Why, teacher, you took a small function? I just want to show you whether the function. So what is your formula? Your formula is f of x equals f of 0 plus 1 plus, f of 0 plus x times f dash of 0. X times f dash of 0 plus x square f double dash of 0 plus x cube f triple dash of 0 plus so on. So your f of x is e power x. What is your f of 0? 1, 1, 1. Everything is 1. So this is 1 plus x into 1 plus x square into 1 plus x cube into 1. So it keeps going, right? So e power x equals 1 plus x square divided. Oh, I missed factorial. Sorry. I mixed factorial, right? So divided by factorial 2. I'm sorry. See. So factorial 2 and here is factorial 3 is there. Okay, right. So this is factorial 2 plus and 1 by factorial 3, or you can write x cube divided by factorial 3, right? Factorial 2 is equal to 2 and factorial 3 is equal to 6, you know very well, right? So my equation will be e power x equals 1 plus x square by 2 plus x cube by 6 plus so on. This is the Taylor series expansion of e power x. Okay, teacher, what are you trying to say? I'm going to say the approximation. Take x is equal to 1. Because with x we cannot predict anything. Because with numerical values only you can predict anything. With x you cannot predict anything. So take x is equal to 1, e power 1. You take your calculator now. So calculator, you press alpha, e and then press power 1 or without 1, which is equal to, in the calculator, 2.71828 and 1828. Okay, in the calculator. Let me start here. 1 plus x is equal to what? X is equal to 1 plus 1 plus 1 divided by 2 plus 1 divided by 6. It keeps going, but I'm stopping, right? So it keeps going. So if I add this one, for example, 1 plus 1 plus 0.5 plus 1 by 2 plus 1 divided by 6, fraction mode, 1 divided by 6 is equal to 8 by 3, which is equal to 2.6666, I think. 1, 2, 3, 4, 5, 6, 7. Sorry, I cannot able to see. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. After that 7. Okay. Look at the original value. This is 2.78. The computer cannot handle until infinity, so it is approximating, we are approximating it to this value. For example, let's say, for example, 3 decimals. Approximate 3 decimals. Let me say 3 decimals. So if I say approximate 3 decimals, what is the answer here? 2.718. If I say approximate here, what is your decimal? 2.666. Okay, teacher, what is the problem? No, we are studying about errors. So errors in the sense we should be very careful in the calculation. Minute values also you should be very careful, like measuring a gold. Okay, right. So this is original value is 2.718 for 3 decimals, but our approximate value is what? 2.666. In this way, any function, I gave you example e power x, like ln x, like logarithmic functions, like exponential functions, hyperbolic functions, sine functions, cosine functions, tan functions, cosecant, secant, cot, whatever the functions in the whole world is available, you can approximate using Taylor's series formula. Okay, so the error, usually you look at the error, for example, you just subtract this error, 2.718 minus 2.666. If you subtract, what will you get? So the error is 0.0520. Suppose you extend more terms, the error will become very small. Keep in your mind. Error gets smaller if you add more terms. So if you add more terms, automatically the error becomes very small. Okay, everybody? Right. So this is the basic introduction about relative error, absolute error, truncation error, rounding error, and then chopping error, and then computer error, and how to approximate the function error also we studied in the first one. Now we are going to do the classwork homework questions, the classwork questions. So some questions are given in the classwork. So let us start our classwork questions now. So the first question is example 1. Determine the 5 digits chopping and rounding values of pi. Okay, so let's start the solution, right? Pi is equal to, go to the calculator, put pi in the calculator, everybody, which is 3.141592654. Calculator is very small for me. Shift pi equals and then 3.141592654. Okay, right. What is the question? First question is chopping. Chopping means what? No need to approximate more than 5, right? So chopping. Yes. Let's chop 3.141592654. How many values? 5 digits they are going to chop. Okay, let's chop for 5 digits. 1, 2, 3, 4, 5. So just chopping here. Okay, so the answer will be what? 3.14159. Okay, next go for B question, and B question is rounding. Yes, rounding means you are going to see this one, right? So this now next digit you have to see. This is also not more than or equal to 2, sorry, equal to 5. So 3.14159, because you see the number is less than or equal to 5. So we cannot do anything. So chopping and rounding is this answer. Let's go to example 2. So determine the absolute and relative error. Okay, and approximating by p star when p is equal to this and p star is equal to this. Usually you find difficult when it gives in 10 power. So what you do, you take your calculator and type the same thing. Come on, type this one in the calculator, same like this. If you type like this, you will get 3.000. Okay, right. And again p star, this is your p, right? Yes. And now you calculate your p star also, same thing, you type this in the calculator. Okay, when you type the calculator, you will get 3.100. I'm doing side by side in the calculator. Okay, right. So p is ready, p star is ready. So we are going to calculate absolute error. So what is the formula for absolute error? Absolute value p minus p star, which is equal to absolute value 3.000 minus 3 not dot 3.1000. So which is equal to how much? 0. I can calculate in the mind, 0.100. So this is your absolute error. Okay, right. Let's go for relative error. I told you relative error is same step but divide by this. So P minus P star divided by what? Absolute value P. I'll take it as granted. I'm not doing it again. So divided by, where is my P? My P is here. So absolute value of 3. I told you relative error, just give it answer in percentage. So when I do it, the percentage will be, I think this will be 300 divided by 3 is going to be 0.33 because it's nothing but 1 divided by 3. And it's 3.33 percentage. You can check in the calculator, no problem. It's very simple. Let's go to the B question. Determine the absolute and relative errors. Same question because he has just given example 1 in the classwork sheet, but it consists of too many questions, but the ideas are same. Okay, so P is equal to, again type this in the calculator. Again type this in the calculator. You will make mistakes. Please remember, type this in the calculator. 0.0003 and P star type in the calculator 0.00031. For me it's easy, I'll do it in my mind, but for you type in the calculator. Let's go for absolute error. So absolute error formula is absolute value P minus P star over this relative error. So this equals, and you put it in the calculator directly. Okay, so it's going to become 0.00001. And the relative error, okay, I told you same formula, P minus P star divided by absolute value P multiplied by 100, which is equal to everything you put in the calculator, 3.33 percentage. So this is your absolute error and this is your relative error. That's all the question. Again the same question, determine the absolute and relative error when an approximating P by P star. Okay, same question, it's repeating, but it's okay. Let's start. So let's do the solution, right? So again you type this in the calculator and get the correct value. Type this in the calculator, again get the correct value. So when I type in the calculator, my P is equal to 3000, and when I type this in the calculator, P star is equal to 3100. So my absolute error, I'm not going to write the formula now, I'm going to write directly, which is 100, very easy. And I'm going to write relative error also directly, okay, right, without writing the formula. Okay, 100 I will write by 3000, okay. So this equals 3.33 percentage, right. So what is the meaning? The relative error is same in all the questions. Why? Because the difference is between P and P star is proportional. Proportional in the sense approximately powers of 10. See here, here also 10 power 4, 10 power 4. And here also 10 power minus 3, 10 power, all 10 power. So whenever it comes 10 power, so it's automatically the relative error will be going to be the same because it's a calculation of percentage. Okay, but it's not needed for you, but I am just analyzing the data. Right, again he has given question 1, compute the absolute error and relative error. Okay, let me do again solution, right. So P is equal to, it has given pi, you put it in the calculator, which is 3.141592654, because I know, that's why I'm writing. And P star is equal to 3.1416, which is given here. Okay, so now absolute error, sorry, oh okay, I want to finish it. If it cuts again I cannot record it. Absolute error is equal to, right, so if you put in the calculator you will get 0.123457346, and you are going to get the relative error, okay, divided by P value, and it's going to become 0.000234 percentage. Exactly, I am not doing, calculator is doing. Let's go to question 1, again same question. Okay, right, so let me do the solution. Okay, right, anyway P is equal to pi, absolute error and relative error, so which is equal to 3.141592654. But P star, you should be very careful, this one you should put in the calculator and you have to get the number, which is 3.142857143. Look here, Even though we take every time 22 by 7 is equal to pi, look at the decimal values. It's totally different, right? Yes. So let me calculate absolute error. Okay, absolute error is equal to, which is equal to, put this in the calculator, 0.0012644489. See, look at this. How much difference is there? Error. So relative error also, you put it in the calculator, divide by p and then multiply by 100, which will give you 0.0402 percentage. Let me check again because I'm not sure the digits, I'm not typing properly. So which is fraction mode, 0.0012644489 divided by p is 3.14159264, which gives, and multiply by 100, 0.0402, yes, and 49935, something like that. I make it as 4 decimal. Usually I always give the answers in the future. Most of the time the decimal numbers are not mentioned. Usually I go with 4 decimal values. Again, what is the next? Oh, next question also same. Let me go to, oh, okay, but different values are there. P is equal to E and P star is equal to 2.718. You know how to calculate E, right? Alpha E. E is in the down. Okay, which is 2.71821828. Okay, again I'll check the values, please. 2.7182181828. Right. So let me calculate absolute error. Okay, so absolute error is equal to 0.000281828, and relative error using the same formula. Okay, right, 0. Okay, you can write in percentage. Okay, so multiply by 100, which is equal to 0.01036 percentage. Okay, clear everybody? Clear or not? So how to calculate absolute error, and then this one, it's clear. Okay, now it's different question, right? Let's go to example 3. Suppose that x is equal to 5 by 7. So x is equal to 5 by 7 and y is equal to 1 by 3. Use 5-digit chopping for x plus y, x minus y, x multiply y, x divide by y. Okay, let me put in the calculator 5 by 7, which is 0.714285,714, and 1 by 3 is 0.333. You know very well, 333. Just now I gave an example, right? What is the first question? The first question is x plus y. So x is 0.714285,714 plus 0.333333. You can do it directly in the calculator, which is equal to 1.047619047. Normally we call it as this one, what? True value, right? Now we are going to approximate it. Chopping, how many decimal? 5 decimal they are asking. 1 2 3 4 5. Cut it here. Chopping, you know, chopping vegetables, chopping, cutting. So 1.04761. This is by chopping. How many decimals? 5 decimal values. 5 decimal values, right? Let's go with x minus y. I have already in the calculator, I stored x value, I stored y value. So I'm just using now x minus y. Easy to do because instead of doing. So let's go with x minus y. So I got the value 0.380952,381. Now chopping for how many decimal? 5 decimal values. 1 2 3 4 5. Chopping. So 0.38095. This is the value, right? Let me go for x multiply y. So I got the answer 0.238095,238. So now I'm going to chop it. I'm going to chop it for 5 decimal values. 1 2 3 4 5. So 0.238095. No. This is 5, 1, 2, 3, 4, 5. See, sorry, for my glasses it looks like 4 decimals. Okay, so it's 5 decimals means 1, 2, 3, 4, 5. Okay, right. Yes, chopping for 5 decimals, right? The next is x divided by y. So x divided by y is 2.142857144. Teacher, can I chop it in the calculator itself, directly write the answer? Yes, 100% you can write. You are all in the 3rd year of engineering, so you can cut the steps, no problem. 2.14285. This is also for what? Chopping how many decimal values? Chopping 5 decimal values. Okay, right. So suppose if the question is rounding, you should be careful. 1, 2, 3, 4, 5. So this number will go as 6. Keep in your mind. Okay, right? Clear? Right. In this way, your introductory material is finished. Okay. Let me tell you again, in the CLO, course learning outcomes, there is no point related to this introduction material. But in case in the quizzes they can ask questions, keep in your mind. It means what? They are just make sure, they just want you to make sure whether you know the idea of true value, approximate value, rounding error and relative error, absolute error, computer errors, truncation errors, and all these things you should know, right? Okay, I hope this introduction gave you a clear start to numerical methods. If you like the way I explain, please don't forget to like, share and subscribe to the channel and inform your friends too. In the next video, we will dive deeper into solving equations, right? There are different methods are coming using numerical methods. Okay, Zahir here signing off. See you in the next video, inshallah. Take care. Bye bye.